At the end of the day, we've got an opportunity which we probably wouldn't have had if the war in Ukraine didn't kick off. And we are being given the opportunity to get work back from places like China if we can get the price right. Every machine shop needs a manual machine.
Hello and welcome to today's MTDCNC podcast. Slightly unusual today because we're actually interviewing, I think that's the right word, having a chat with Martin Locke from PES Engineering, who is an end user, a subcontractor. Martin, thank you for, did you agree to join me today?
Of course, always welcome.
Brilliant, thank you. So we've been filming at your machine shop today. How long has the company been going?
The company was incorporated back in 1957, so older than me.
Older than you, so by my maths, 55 years, but you've been here?
I've been here 25 years doing this position.
Okay, so a few trials and tribulations on the way, but I want to know, before you came to the machine shop, what you're doing, because it was quite an interesting job, I understand.
Yeah, I used to have work for a corporate R&D background. My challenge was to see if we could make it in production world.
Yeah, but more importantly, you make it and then smash it.
Absolutely, that would be one of the tasks someone would ask me. Just try to do something to test to destruction.
And how, I mean, were you machining it? How were you testing it to destruction as such?
Anything. Could be a turn part. I'd make components for tooling to make press tools, and then instead of annealing the material, they'd just go straight in hard and smash all my tooling to pieces.
Right, okay. What is the most difficult material there that you've ever sort of smashed or played with, should we say?
I had one challenge, molybdenum, but worse than molybdenum was hastelloy, a work hardening material. So as you cut it, it gets harder.
Right. So, and did you smash it though?
Yes. 25mm drill.
Right.
3 places broken, three drills.
What a great job to have. Building it, smashing it, and designing it as well. Still
Pressures are constraints with time, I'm afraid.
Okay.
Only given a month.
Right, okay. So a little bit of pressure, but I'm assuming now you've been PES because it was your father's company?
Yeah, correct.
So PES 25 years, did you say?
25 years for me here as managing director, and a few years before when my dad was still running it.
Right. Was it? I assume you sort of switched from machining it and smashing it though.
Yeah, we was manual machines them days.
Okay.
We're primarily CNC now.
But you're not smashing components, is what I'm alluding to.
Absolutely not. Cost money.
Absolutely brilliant. So what I want to do is, I mean, you've got a great little machine shop out the back there, and some great machines. We'll come to your newest investment, which I think you wish you'd done a few years ago, maybe. But first of all, we're going to go through some of the. I'm going to pick in. Well, first of all, what challenges as a subcontract engineer do you have at the moment?
Most like most people, it's cost.
Yep. Cost of what?
Cost of the component, trying to get it as competitive as what we can to keep the work in the UK.
Okay, so when you say cost, your material costs, I'm assuming?
Yeah, material costs obviously 350% increase across the board, mostly.
Wow. Are you seeing sort of daily, weekly, monthly price changes?
I have to say the last 6 weeks we are seeing that curve stop, and it's on the downward spiral for stainless steel, which is a relief.
Good, so you can make some more money?
Not so much making more money, but also as well, we can't get hold of it. There's no stock.
Yeah, I think it's a lot of challenges faced by a lot of all the engineers out there at the moment. What about also, you say cost pressure, what about things like onshoring?
At the end of the day, we've got an opportunity which we probably wouldn't have had if the war in Ukraine didn't kick off. And we are being given the opportunity to get work back from places like China if we can get the price right. And we need to do that.
You say the war in Ukraine, how are you tying that in with getting stuff back from China though?
Obviously the world is a small place now, and you know, made in the UK is back in vogue.
Absolutely. Well, I mean, UK engineering, I think it's got to be one of the best in the world.
I've got some American clients, and I don't need to sell myself, is the best way of saying it.
Right. And what sort of industries are you working for then?
Railway, electronic, medical.
So some complex parts, I'm assuming.
Absolutely. You know that it's machinery has made it easier, but ultimately you've still got to hold a tolerance.
Absolutely. And talking of holding tolerances, you've got some great machines out there. And again, I alluded to your latest investment. We'll come to that. We'll do a big reveal later. But I want to go through some of your machines because we have visited you before and reviewed some of those, but we haven't reviewed the one I saw tucked away in the corner, which was supplied by a Percy Martin, I understand.
Yeah, we've got a Colchester lathe.
Still going strong?
Absolutely.
Can you run it yourself?
Unfortunately, I am the only one who runs it nowadays. Everyone else is on the CNC. So I make the tooling and some of the fixturing, to allow us to make the parts quicker.
Right, but how old is that one?
It's probably in excess of 30 years, to be truthful, but we've had it from new. And to be truthful, we used to make parts for Colchester Lathe.
And you're still writing off depreciation in your accounts for that?
No comment.
Brilliant. But still going strong, still holding tolerances and still being used regularly.
Every machine shop needs a manual machine, and that one owes me nothing.
There you go, that's what you want to hear. So that's your old Colchester. You've got some other older machines, but still going strong. One of them was, now, you are sort of known as a miller and a fixed head turner, is that correct?
Yeah, I mean, predominantly milling isn't round, so it was more interesting to me to do milling.
Right, so that is your preference, but it might change as well. Again, I'm alluding to your latest investment, but we'll come to that in a little while. So you've got an old Cincinnati.
Yeah, we've got 2 Cincinnati VMCs. Again, testament of time. They just work.
That's it, nice and simple. When you say they just work, in what aspect?
They're 3-axis CNC machines, tool changers. Why do I need to get rid of something which is still doing the job? They're quite quick, and I don't do 5-axis.
That's it, nice and simple. And they're quite quick, because how old are they?
Oh, again, 1997.
Really, and still going strong, still holding tolerances.
I'm lucky I've still got a couple of service engineers who are ex-Cincinnati, so if we have a problem, we can sort it out and keep going.
Ah, brilliant, but a great testament to these old machines. That I mean, can we say that they don't make them like they used to, without offending our clients on MTDCNC?
I think they're easier to fix.
Right, more mechanical, is that why? Or?
I'm not more mechanical, but some of the older electrical components don't seem to break down as often as the newer stuff, would be the political way of saying it.
Okay, we'll say no more on that then. We'll moving on swiftly. Now, I did also notice out there a Hardinge, is that right?
Yeah, I've got an XR1000, newer machine, six years old. Definitely a lot faster than the older machines. 48 metre rapids, equates to 700 millimetres a second. It's quite fast.
Okay, any interesting jobs you're doing on those?
Regularly do medical dishwasher components, which are going across the world.
Right, but those medical dishwasher parts, they're sort of, you're turning, milling those, but they're being also welded, brazed.
Yeah, we get involved with assembly work, so I might make the component parts to be made into an assembly. We might get it back for subsequent machining. So yeah.
All good. Now then, another one. Well, I'm getting the feel here that they're your favourites, or love all the machines for all different aspects. But moving on, one of your newer machines, a nice DMG miner. Let me get this right. NLX 2500 700. If I got that right.
Absolutely, yep. 700 means the length.
Yep.
Quite a large fixed headstock CNC lathe, kissing spindle, milling.
When you say kissing spindle,
you've got one spindle one end, one spindle the other, sub spindle.
Yeah, so twin spindle. I've never heard that phrase, a kissing spindle, so moving across, taking the parts essentially.
The older machines never used to go all the way, so you couldn't take it actually out the chuck without extending the jaws. So the modern machines can actually kiss.
Right, I've got to see, always, that's a great thing about engineering. Every day you're learning something new. I've never heard that phrase before, so there you go. If you haven't learned anything from this podcast, kissing spindle. Is that right?
Absolutely.
All good. So that though, I mean, we're getting on to your fixed head turning, all driven tooling?
I wouldn't buy a machine without driven tooling. Obviously, evolution of that, colour Hardinges don't have Y-axis, but the modern machines, I think, it's just a given. You've got to spec up as high as what you can afford, and that's got to be to include a Y-axis.
There you go, simple as that. So making more complex components, I should imagine.
You just want to get it off in one operation. It's just cheaper for the end user, to the customer, a better part, better components, better quality.
There you go. Now, I'm going to take a step back to where you were before. A lot of your parts, you sort of reverse engineering, because you had sort of an R&D background, is that right?
Yeah, I mean, I will do reverse engineering, whereby the customer may give me the challenge to manufacture something for mass production. So I will try to evolve their product to be made least cost.
Right, so a great example was, and we've done a review on your latest machine, and there's a Delrin part. How did you work that one? What was the story there?
Basically, was asked to look at something which was currently planned to be moulded, injection moulded. There was quite a high cost for the tooling, with obviously no flexibility should they change it, or a lot of money to change the tool. I basically was given a brief for cost, and could I design out all the features to get it as cheap as possible.
Right, that's interesting because the part itself, I mean, in terms of injection moulding, looks quite complex, because I'm thinking injection moulding not too complex a part, but there's a lot of threading, slotting, grooving, milling, drilling, whatever it may be.
Absolutely. I mean, my background isn't that type of thing, but at the end of the day, I'm sure someone somewhere will say you can do it. I think the primary reason of problems was the thread, and it's in the oil industry, and for whatever reason in injection moulding, they had a problem with oil ingress, whereas the turn parts don't.
Right, simple as that. So you're now making this, and you make it on your new machine. I've alluded to the new machine already, but I've got one more thing before we get to that. What are your views on automation in the machine shop?
I think you've got to automate to carry on. Like we said various times, the end user, the customer, wants things very competitively, and you've got to automate to get there.
When you say automation, what sort of types of automation are you thinking of, and do you think it's readily affordable for, and no disrespect yourself, a smaller machine shop though?
If we look at our milling capacity, obviously doing more than one thing at a time, so maybe special fixturing, which is something I can do. So we might do 10, 15, 50 components at a time to get the cost down through one load. You can put more work holding in now for vices to do more than one thing at a time. But then you move on to turning, and the beauty of turning with a bar feed is the clues in the description. You can bar feed a lot more material, and it's autonomous.
There you go. And do people think, when you're talking automation, do you think bar feed? Because I'm thinking automation, pallet loaders, robot arms, but yeah.
I'm not saying that I wouldn't buy one of those. The facts are, at the moment...
You might get a few people knocking on your door after hearing this podcast.
Human beings are very dexterous, and at the moment, for the type of work we do here, which is smaller batch, I don't think the robot loading is something which we would go into right now. That said, we hope to carry on. So at the end of the day, another job might come in tomorrow, and we might buy a robot loader. But CNC turning or new acquisitions can automate a lot easier.
Okay. Now, you said that, so sort of alluded to the fact that you're a miller and a fixed head turner, but it's all changed. What have you gone and done?
I've entered the sliding head market.
Why?
Flexibility. I've mentioned it various times on your visit today. It's got to be flexible.
And when you say flexible, what sort of flexibility, what sort of points are you alluding to?
Size of material, so from sort of small bar through to 38 mil in my case. All different materials in all different forms. And of course, you can turn a round part into a square part now.
Right, okay, so there's three things there. So in terms of size, because you've got let me get this right, Citizen Syncom L32 Type 10 with LFE, 32 mil bar.
Yep, I've got exactly that, and we've also got the oversized kit, which takes us up to 38 if we need it.
So you can get some big bar, but also you've got the oversized kit, but you can go non-guide bush as well.
Absolutely, and that just makes your remnant a little bit smaller, which saves costs, and it's less tooling.
Absolutely. And then flexibility in terms of, you're a turner miller turner, but this gives you that flexibility to do your milled parts as well on that.
I am now seriously looking at taking some of the milling work and putting it onto the slider, simply because I can put a 3 metre bar in the back of it, or 10 of them for that matter, in a magazine bar feed, and it just runs unmanned. And as we all know, lights out unmanned means bigger profit.
And it means you can sit home having a beer while it's making you money.
That's always the end goal. I think every male would say that.
Absolutely. And let's just drop in there. You can sit at home having a beer on the sofa in your own built house, which I've seen a picture. Guys, I have to say, absolutely beautiful. So great job on that.
Thank you.
Don't know how you had time to do that and run an engineering company as well. But
there's 24 hours a day.
Moving on. Great house. But so you've got the new Citizen machine with the LFE. A phrase you said earlier as well is the swarf. That paints a whole picture. What's happening with that?
We cut quite a lot of stainless steel here. I'm quite happy to cut brass, but the reality is we cut anything which comes through the door, and 50% of what I do here is stainless steel, and that has problems with swarf control, and LFE just solves that problem.
Okay, and also the storage of the swath, because before it's all big and stringy and you'd have to store it in like 10 containers now.
Absolutely. I mean, we have a large piece of wood which has been here for probably 3 decades to ram the swath down, and you don't have to do that with LFV.
So the piece of wood has now been made redundant.
Absolutely.
Did it cost you much?
Kind of looks like a cross on a tombstone, so...
Fair enough. So it's giving you that flexibility, but in terms of what, because you're known for milling and fixed head turning, you're now this has opened up doors so you can do bigger batch runs.
Yeah, I mean, I'm known to do a larger batch size and deliver them monthly. That gives the customer economies of scale, and they are quite happy that I'm stocking them. The agreement, obviously, is they take care of the issue control should that change. But yeah, I mean, the sliding head opens opportunities of larger batches, which, you know, we all like spindles to be machining and turning.
Okay, now two final things. You are new to sliding head. People out there, you know, you see there's a lot more sliding head machines coming onto market and into machine shops. If someone hasn't got a sliding head, three things. Do you wish you'd done it sooner?
If I can find the work and they're very hungry for work, who wouldn't buy one of those?
Okay, and again, you're new to sliding head. Has it been easy to, not that transition, but has it been easy to learn, easy to program?
I've got to say, it was a lot easier than some of the other machines I've got here. The stress is always interesting when you get a new machine. And as is always the case, you always seem to get a short lead time when you get a new machine on a component. So far, and I'm sure there'll be challenges, but they've not been too bad.
Brilliant, so that's great to hear. Martin, great bit of history about PES Engineering, and this has now opened up new avenues to you. So in a nutshell, I think we are going to get a bit of PR for your good self. You are now looking for big batches on your slider. Is it as simple as that?
I'm happy to take any batch sizes. I'm not fussy, but yeah, I mean, if someone's out there and they want to give us a go,
Yeah.
I'll give them the same quality as what we've given for the last 55 years, a good price.
Brilliant. And also, that's just, see, I'm coming up with another point. I do apologise, but that's key. That slider, you're thinking it's big batch runs, but it's very easy to set, so you can change over and do much smaller batch runs if required.
Well, I'm proof of that because I don't do the larger batch runs at the moment.
Yet.
And consequently, I'm quite happy to knock off 1,000. My biggest problem is having a cup of tea and it's made another 200 by the time I've read my emails.
Great problem to have. Martin, thank you very much for joining us. PES Engineering made a new acquisition and probably going to make another one in the not too distant future. Thank you very much for joining us. That's Martin Locke from PES Engineering, and my name is Colin Griffiths from MTD. Hope you enjoyed this week's podcast, and we'll hear from you, see you very soon.
Thanks, Colin.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.